If y is equal to 2x plus 3 all raised to the power of 5, we are asked to find the change in y with respect to x. The function before us is not the same as this function, y equal x raised to the power of 5. This is a simple function. Why this function is a composite function? A composite function is simply a function inside another function. Now, looking at this function, 2x plus 3 is the inner function. That is 2x plus 3 is the inner function. While 2x plus 3 all raised to the power of 5 is the outer function. 2x plus 3 all raised to the power of 5 is the outer function. Let's call this inner function u. Of course, this outer function will be equal to y because this is the same as this. Now, if u is equal to 2x plus 3, we're going to replace 2x plus 3 with u so that y will be equal to u raised to power 5. This is also the same as our outer function. To find the derivative of this composite function, we're going to be using the chain rule. That is, the change in y with respect to the change in x will be equal to the derivative of the outer function multiplied by the derivative of the inner function. Now, if y is equal to u raised to the power of 5, the derivative, the change in y with respect to u will be dy du times, if u is equal to 2x plus 3, the change in u with respect to x will be du dx. Now we are given y equal to u raised to power 5. The change in y with respect to u will be equal to 5u raised to power 4. The exponent 5 will be used to multiply the coefficient of u, which is 1. 5 times 1 is 5. The exponent 5 will be reduced by 1. 5 minus 1 is 4. Times, if u is equal to 2x, the change in u with respect to x will be 2. Now, the exponent of x in this case is 1. 1 times 2 is 2. The exponent will be reduced by 1. 1 minus 1 is 0. X raised to power 0 is 1. 1 times 2 is 2. The derivative of constant is 0. So this will be equal to 5 times 2, which is 10u raised to the power of 4. Now, dy dx will be equal to 10. U is the same as 2x plus 3. We're going to replace u with 2x plus 3. This will be 10 bracket 2x plus 3, all raised to the power of